Hi, this is Mrs. Kidman, and in this video, we are going to be discussing how we can solve rational equations. So when it comes to solving rational equations, we're either going to see two things. We are going to see just an equal sign between two expressions, or we are going to see an add and subtract sign with that equal sign. So if we only see an equal sign, what we're going to do is we are going to cross multiply and then solve. Simple as that. 2 steps. We have to use the distributive property in there if you want to have 3, but that's what we're going to do. If we have an add or subtract problem, what we're going to do is multiply by whatever cancels out our denominator. And so what happens there is every single piece might have a different denominator. So to cancel out that denominator, what we do is we use something called the largest denominator. And all that means is we're going to look at each piece and say, I need to cancel by this, and I need to cancel out this, and that's going to be our largest piece to cancel out. So multiply by everything, multiply by a number that'll cancel out everything, or an expression that'll cancel out everything. Then once we cancel that out, what we're going to do is actually cancel it out. And after we've actually canceled it out, then we are going to solve our equation here. So what we want to do is we want to run through this problem, run through a couple of problems here where we actually solve it out completely. So let's take a look at this first one here. Notice how there's an equal sign. That means I'm going to cross multiply and then solve. So I've got 3 times 4x plus 5 is equal to 9 times x plus 1. And that's all we're going to do to solve that, is multiply it out. So we get 12x plus 15 equals 9x plus 9. And then we solve for x here. I'm going to move my 9x to this side, move my 15 to this side, and I get 3x equals negative 6, which means that x equals negative 2. Now notice how this question says check for extraneous solutions. Remember, extraneous solutions are also known as fake solutions, or answers that we get but don't actually work. The way you check to see if an answer is extraneous when it comes to solving rational expressions is you put your answer into the denominator and see if it makes any of our denominators 0. If it does, it's extraneous. If it does not, then we are good to go. Okay, so that is how we can do one where they're set equal to each other. If you would like to try another one, here's a great example where we do that. So take a second, pause the video, work this out. When you finish doing this, unpause the video, and I will go over it quickly. Okay, so hopefully you've had the chance to work this one out on your own. Again, just like before, we're going to cross multiply these. So we get 2 times 5x is equal to 3 times x minus 7. And what we do is we use that distributive property. So we get 10x is equal to 3x minus 21. We move our 3x to the other side through subtraction. So we get 7x equals negative 21. Divide both sides by 7, and x equals negative 3. Now to check to see if that's an extraneous solution, we plug it into both those denominators. If I plug a negative 3 in, I get 3 over negative 15 is equal to 2 over negative 10. Awesome. Neither of those denominators was 0, so we know that that's a real answer. And that's how we do it when they have an equal sign. Now, what happens when we have a plus sign? Well, that very first step that we talked about at the beginning of the video says multiply by like the largest denominator. This quote unquote largest denominator is the least common denominator, or basically what I need to multiply by to get rid of all the denominators. So what do I need to multiply by to get rid of the denominator in the left equation? Well, that one has an x. So I got to do the opposite, which is multiply by an x. That'll get rid of the left one and the one on the right. To get rid of the one in the middle, I need to multiply by 4. So I'm going to multiply everything times x and times 4, because I can't just multiply each piece by something individually. The whole expression, the whole equation has to be multiplied by the same thing. So I'm going to multiply everything times x times 4x, or x times 4. And so what that looks like is I just take this. This is a fraction of multiplying it over 1. So I just take my numerator and put those two things in there. So 5 times x times 4 over x plus 7 times x times 4 over 4 is equal to negative 9 times x times 4 over x. Then what we do is that cancel step. That means get rid of whatever is in common on top and bottom, just like we have been. In this case, it's our x's. This case is our 4's, and this case, it's our x's. So then what we're left with over here is 5 times 4, or 20, plus 7 times x, which is 7x, is equal to negative 9 times 4, which is negative 36. I can subtract 20 from both sides here and get 7x is equal to negative 56. If I divide by 7, that means that x is equal to negative 8. And just like before, we do want to check these solutions for extraneous answers by plugging it back in. If I put negative 8 in for x in these two expressions, in none of the cases will we divide by 0. So we know that that's a true solution there. Okay, let's take a look at 2 more examples here. where they look a little bit different, but still will work out. So in this case, we're going to multiply, just like we did before, by that largest common denominator, or whatever that number is that cancels out all of the denominators. So in this case, that first one has no denominator, so we don't need to multiply by anything. The second one has a denominator of x minus 5, so that's what we multiply by. And the third one has a denominator of x, so we multiply by that. Now, just like before, everything on top gets multiplied by that. Where that first term 1 doesn't have any denominator, that means that the numerator, or the number 1, will get multiplied by those things. So I've got 1 times x minus 5 times x, minus 8 times x minus 5 times x over x minus 5 is equal to 3 times x minus 5 times x over x. Then just like before, we go through and cancel. In this first case, anything times 1 is itself, so I'm going to cancel out that 1. But basically, it looks like that. Cancel out what's in common on top and bottom, and we end up getting x times x minus 5 minus 8x is equal to 3 times x minus 5. Then we want to use our distributive property to solve this, just like we always would. And so we end up getting x squared minus 5x minus 8x is equal to 3x minus 15. And then we can go through and solve for x here by combining like terms. So we get x squared minus 13x equals 3x minus 15. I can add 15 to both sides. I can subtract 3x from both sides, and we get x squared minus 16x plus 15 equals 0. Now that we have this, what we want to do is factor it out to figure out what our solutions for x are. So we want two numbers that multiply to 15 and add to negative 16. That'll be negative 1 and negative 15. So we get x minus 1 and x minus 15. Both of those are equal to 0. And so that means that x equals 1 or x can equal 15. Now, when we get two solutions like this, we do want to check to see if either of them are extraneous solutions. So we want to put a 1 in. If I put a 1 in here, I would end up getting 1 minus 8 over negative 4 equals 3 over 1. Okay, option number 1. Our second one, if we put in that 15, we end up getting 1 minus 8 over 10 is equal to 3 over 15. Great. Are any denominators 0 there? No. Because none of our denominators are 0, these are actually going to be two possible solutions. So we can have multiple solutions to these questions here. Now, let's take a look at one last example. Before, our denominators have always been in their simplest forms. We can't factor them out. But in this case, we end up with a denominator in the middle that is not in its simplest form. It can actually be factored. So right before we multiply by what's most in common, we want to factor it out, because by factoring it out first, then we know what we can cancel out here. So in this case, we really have this expression here that factors out into x plus 3 and x minus 3. So what happens is when we go to multiply this, to get rid of the denominator on the left, what we're going to do is we want to multiply it by x minus 3. To get rid of the denominator in the middle, it needs to be multiplied by x plus 3 and x minus 3. That'll get rid of both of them. And the one on the right needs that x plus 3. So because of that, this whole thing is going to be multiplied by x minus 3, x plus 3, or x squared minus 9. Now notice, if we had not factored that out first, we would be multiplying by an expression that is x minus 3 times x squared minus 9 times x plus 3, and that is just tedious. There's way more work than we should have to do. So by factoring out first, we can make the problem simpler. So let's go ahead and do that. Now we have 6 times x minus 3, x plus 3 over x minus 3 is equal to 8x squared times x minus 3, x plus 3 over x minus 3, x plus 3 minus 4x times x plus 3, x minus 3 divided by x plus 3. And then we can go through and cancel out what's in common on top and bottom of each of these fractions here. And we end up getting 6 times x plus 3 is equal to 8x squared minus 4x times x minus 3. And now what we want to do is go ahead and factor this so that we can solve it out here. So as we factor it, we get 6x plus 18 is equal to 8x squared minus 4x squared plus 12x. And then what we want to do is move everything to the same side and combine like terms. so that we can end up setting it equal to 0 so we can factor. So we end up getting a 4x squared. 12x minus 6x is going to be plus 6x and then minus 18. And so what we want to do is we can try to figure out what numbers will work in this situation there. And so just to start, we want to factor out our greatest common factor, which is a 2. So by factoring out a factor of 2, we end up getting 2 times 2x squared plus 3x minus 9. And then what we can do is multiply the first times the last. So we want two numbers that multiply to negative 18 and add to 3. Well, that'll be 6 and negative 3. And then we have to divide both of them by 2. And so we end up getting 3 and a negative 3 halves. And so then as we write this out, we get 0 is equal to 2 times x plus 3 times 2x minus 3. And then as we go to solve for x, that means x either equals negative 3 or x equals 3 halves. And now with both of these solutions, we want to check to see if any of them are extraneous. So if I put a negative 3 in here, notice right here, if I put a negative 3 in, I get a denominator of 0. So guess what? That is not a real answer. That's an extraneous one. So our only answer here is that x equals 3 halves. But that is how we can solve these rational expressions here, by studying them by using cross multiplication. If they are just an expression equals an expression, if there's any add or subtract sign, then what we're going to do is multiply by that largest denominator that cancels out all of the other denominators. If you have any questions, don't hesitate to ask.